All right, guys, we're going to begin this chapter on systems by talking about solving systems by graphing. I put you a couple of notes in on the description. I hope you guys read those before you actually just dive into these. But solving systems by graphing is a useful tool. I will go ahead and caution a little bit that when you're solving systems by graphing, it is subject to how good you can graph. And of course, we know especially me trying to draw, it doesn't work out real well. Of course, we could use a graphing calculator for this task too, but I really want you to be able to do this by hand, at least now, and that is going to prove useful. We're going to see that there are some limitations even beyond just the ability of being able to graph neatly. Once we get a little later in this chapter, you're going to figure out that there are some systems you cannot graph. But today we're going to be talking about solving systems by graphing, and this is very useful when you already have your equations in slope-intercept form. So, for example, look at these first two, and we're going to work through a couple of these, and I've got one more I want to show you here in just a few minutes. But these are very useful when they're already in slope-intercept form. So you notice in both number one and number two, they're already in the y equals mx plus b slope-intercept format. So it's very useful to be able to graph these. So let's just jump right in. Let's look at number one here. And so what you're going to have to do on Cami, that's the reason I wanted to do this on Cami so that you can kind of get an idea of how this could work, is you're actually going to have to graph these lines here on Cami, and that's going to help you to try to find your solution. So let's just start with this top one. Why not? We'll just take one of these equations at a time, graph them, and you know that the solution to the system is wherever those two lines intersect, okay, the coordinate pair that those two lines intersect at. So let's look at this first one. Go ahead and try to graph it. So we're always going to look at the y-intercept, right? So it says positive 9 is my y-intercept. And what I can do over here, you notice there's all kinds of different tools that you can use. And under this one where it says shapes, you can actually choose a circle. It says ellipse. You can also choose how thick that is. We'll use a thin line for this, as well as the transparency. You can make it less or more transparent. We'll put it about in the middle, and you kind of get an idea of what that is. And for this illustration, we'll just use red. That's what it's got chosen for us. So I'm going to go ahead over here and go to positive 9, and I'm going to go ahead and put me a point right here. Okay, so there's my point, positive 9. And then I'm going to use my slope here. Now you're going to think automatically, wait a minute, that says I've got to go up 11 and over 6. Well, I'm already at the top of my graph. Well, keep in mind that that is a positive slope, and that doesn't mean that you can't go down and to the left, because down and to the left would be negative over negative, which would end up being positive. So let's just work this out. It means we need to go down 11 and to the left 6. So if I go down 11 from here, I'm already at 9. I'm going to go all the way down to 0 and down 2 more. That's 11. And then to the left, 6. So 1, 2, 3, 4, 5, 6. I've still got my circle tool. So I'm just going to go ahead and put another one right there. There are my 2 points that I need to make a line on. Okay. So again, you've got a line tool right here. And we're just going to use that same color red. And we'll keep the same thickness. Why not? And literally what I can do is I can go ahead and just start my line right here. You can just left click and then pull that down, and you can see how it begins to try to draw that out for you. So we'll go ahead and do that right about there. Close enough. Looks good. All right, now remember, I've still got my line tool chosen, so I need to go back and choose my circle tool because I need to graph this other line as well, okay? So I'm going to go to negative 1, which is going to be right here on my y-intercept. And just drawing that other circle just because I'm recording this video. Yours won't do that, obviously, but again, just put you a point right there. And then here is my slope, 1 over 6. So rise over run, I'm going to go up 1 and over 6. So up 1 over 6. I went up 1. Here's 1, 2, 3, 4, 5, 6. Here would be my other point right here. Okay. Now I could go ahead and use my line tool again and try to see, and you can start to see where these are going to intersect. Okay. So go ahead and do your line right here. Pull it through, and we want to go all the way, right? So that it crosses through and it kind And and you see even my graph is a little bit off, right? But you can get the idea of where these two lines cross. It is actually right here where this other point was. That's kind of accidental, but it worked. So let's think about what our ordered pair is. That is our solution to the system. Again, we always start at the origin, and we're going to count over on our x-axis. So we're going over to -6, and we're going over to -2 on the y. So what I would need you to do now is to go up to your text box. A lot of you have did this a bunch, so you know how this works. Go up here right beside of your answer in the top right-hand corner of your graph, and I want you to go ahead and put in your ordered pair. So ordered pair always starts with a parenthesis. We would have -6, comma, -2. So that would be our solution for that system. So that's basically what I'm wanting from you. I'm wanting you to go ahead and graph these just like we did this one, and then put in your ordered pair. I do want to talk just for a second about this one, because I know once you see this, you're going to think, oh my, what in the world is that? Well, I want you to think about what kind of line that really is. And this may be something you already know, and if it is, great. But I think this is probably going to be a question that we're going to get. So this bottom one, let's deal with it first. So I'm going to go ahead and grab my shapes again over here, and I'm going to grab my circle tool, and let's go ahead and graph this bottom one. So it's y-intercept at -1. So we do that real quick, and then we're -5/4. So I'm going to go down 5, 1, 2, 3, 4, 5, and over to the right 4, 1, 2, 3, 4. And if you ever have questions about that, think about where your line's going to go. This line is going to go downhill, which in fact makes sense because it's a negative slope. So it should go downhill from left to right. So that's one way that you can kind of keep up with that and know what's going on. So I'm going to go ahead and get my line tool, and I'm going to go ahead and make this line here. Voila, there we go. Now I want to think about y equals -6. There's no slope here. There's no x term at all. It just says y equals -6. Well, let's think about where y equals -6 at. I'm going to go ahead and get my circle tool. And if you notice, y equals -6. Well, this is my y-axis. Where is -6? Well, it's right here, right? So I can conclusively say that y equals -6 right there. But that doesn't help me because it doesn't give me a line. Where else does y equal -6? Well, what about, say, right here? Now, of course, x also equals -6 right here, but the y equals -6 right here. What about way over here at this point? Well, of course, x equals 10, but y still equals -6 there. So now if you notice what kind of line that we actually have a horizontal line. Okay, so this is the equation of a horizontal line. Now, I want you to think about, well, what if that was x equals -6? Well, x would equal -6 over here. It would also equal -6 over here, and matter of fact, here as well. So if it was x equals -6, that would be a vertical line. So you need to kind of keep those two equations in your mind. And of course, here we can clearly see what our ordered pair is, our solution to this system. So again, we would just put in our text box and go ahead and put our parenthesis. And we notice that it crosses at 4, -6. So 4, -6 would be our solution right here. Okay, so now let's take a look at one more, because again, those that have the y equals, the slope intercept form, are really conducive to doing graphing. I want to show you one that's not very conducive to doing graphing at all. Look at number 7. If you notice number 7 here, it does, sorry, we did not need that. We need this. Sorry about that. So if you notice in number 7, we do not have these in slope intercept form. So if you're going to have to graph, solve a system by graphing, then you're going to have to be able to rearrange these terms, okay? And that's a very useful thing. So if you think about this, in order to get this into y equals mx plus b slope-intercept form, I'm going to have to take this 10x and move it across the equal sign. So you're going to have to do some rearranging of some equations. I'm going to go ahead and do another text box. We'll go ahead and do this in red. It's fine. So I'm going to put this just above this. So if I take this 10x across the equal sign, it's going to become negative 10x. And so if I rearrange this, I'm going to get y equals negative 10x minus 2 as one of my equations. Boy, that is really large, but it's okay. Now let's think about this one. This one as well, I'm going to have to do the same thing. I'm going to have to get this x across the equal sign. So again, I'm going to have to rearrange these terms. And so in order to do that, I would have to move that x across the equal sign, so it would become negative x plus 7. So there now would be my two equations that I would need to solve or need to graph in order to find the solution. So a lot of these are this way. Again, I want to make sure that you know how to rearrange terms, as well as I want to show you how that when systems of equations are in a certain form, they can be much easier or much more difficult to solve by certain methods. So we need to really become good at different methods to solve systems and not just be dependent on one particular method. Graphing, again, is a great thing as long as you're accurate and as long as you're not dealing with more complex systems like we're going to get to later in this chapter. So hopefully this has been helpful. I've given you at least a couple of examples that already have answers. This one I've kind of started for you. There's only 12 questions on this, so we should be able to do this task pretty easily. Thanks, and if you have any questions, just let us know.